let's add this one more router to the mix. So this is going to be R1 now, connected directly to R4, and it is going to be in AS100. The peering between R4 and between R1 is going to be between directly connected interfaces, so no peerings between the loopbacks. So peering between here and peering between here, and this is just going to be a regular eBGP session. So let's bring this router to the mix. So I'm going to bring it in here. And just going to bring that interface up. And this is going to be fast Ethernet 00. So on R4 interface, fast Ethernet 00, no shutdown. And the interface is up. Let's see if I can ping it. Okay, I can ping it. Now, I just noticed here there is one little wrong piece of information. This is actually 14, not 12. So apologies about that. I'm going to try to correct it. Just noticed it with the corner of my eye. It made no sense before. So I had this tiny little error on this picture. But anyways, between R1 and R4, I can ping. Let's say here. This works, so let me bring in my notepad, and I don't have that BGP configuration template handy, but I know where to find it. So this is where I'm going to get it from. I'm going to copy this information here. So this is going to be BGP community new format. So this goes on R4. I actually don't need this because it's already there. So let's see what we have here. Neighbor is going to be 14.1 remote AS100. So this is going to be, well, I don't need next hop self either. Let me see, is this all I need? Yes, it is. On the other one, I will need BGP upgrade CLI and answer yes. So here that will produce an error message, but I don't really care about that. This changes to 100. This changes to 2456. And this changes to 4, 4, and 4. And let's go to R1. And when I paste this in, show IPBGP summary, it should be coming up. There we go. It just came up while my impatience was kicking in. So now if I do show IPBGP, I do have my routes in place. Let's advertise the network 192.168.0.1 mask. So I'm going to advertise the network of R1, the loopback of R1. If I do show IPBGP, I should be seeing it here. And all the way on R9, all the way here, I should also be able to see this network. If I do show IPBGP, there it is. And I should be able to ping between these two. So from R9, I can ping R1. So now we have network in place here that is very, very good network to actually test some of the more advanced features of BGP. So the next thing that I'm going to talk about is going to be some sort of filtering in BGP, and it's going to be route propagation control. So let's start with route propagation control. So it's going to be relatively simple requirement that we are going to have. So on R9, I would like to create 4 new loopbacks, or actually, let's say 3 new loopbacks. I want to create loopback 100, which is going to be, let's say, 10, 0, 100, 10.0/24. I want to create loopback 101, which is going to be 10.0.1010/24. I want loopback 102, which will be 10.0.102.0/24. So I want to create these loopbacks. Oops, that is not exactly what I wanted. So I want to create these loopback interfaces here, and I want to advertise these loopbacks into BGP making sure that they have incomplete origin on all routers. So here's my question to you. How would you advertise these routes in BGP and have them have incomplete origin? The answer that I am overwhelmingly getting here is simply redistribute. Now, when you redistribute the routes into BGP, you are going to have an incomplete origin. That's very good, but there is a problem with that. Now, if you tried and remember what we did in last couple of sections about this BGP, I gave you a couple of tasks. Do this, don't redistribute. Do this, don't redistribute. Do this, don't redistribute. Well, that don't redistribute still holds true. We are in the BGP task still. So why do you think that redistribution here would be the correct solution? Yes, that's the one by default, but what if there was an explicit requirement here? Do not redistribute. So if you are not allowed to redistribute and this creates incomplete origin by default, what other option do we have? Well, we can always use the route map to modify the attributes, and origin is just one of the attributes, that is actually used in the best path selection process to determine which route is the best route. Now, it's also one of the mandatory attributes in BGP together with the AS path and the next hop. When you use the network statement to advertise routes in BGP, they're going to have the origin of IGP. So we can see that here. So this I here stands for origin. So this doesn't mark the internal route. It says that this route has the attribute called origin, which is internal, or origin is IGP. Now, this is not to be mistaken with this I here, which indicates whether the route is internal or external. So this route here says that this is an internal route. The absence of this I says it's an external route, but this origin here is actually an origin code, which you can see here. So the origin IGP is better than EGP, which is better than incomplete. So my task here says advertise those three loopbacks from R9 and make sure that they have incomplete origin, but do not redistribute. So to do that, I'm going to go to my text editor here, and I'm going to create those three loopbacks. So I'm going to say interface loopback 100, IP address 10.100, or actually it was 10.0.100, let's say 9. Don't forget to give it /24 mask. So I'm going to have two loopbacks here. Then I'm going to create the route map, and I'm simply going to call it set origin, and I'm going to say set origin incomplete. Then I'm going to go to router BGP 900 address family IPv4, and here I'm going to say network 10.0.100.0 mask, and I need this 3 times, so I need it for 101, 102. But where do I put my route map? Now, going back to the task here, well, I didn't write it down. Oh, yeah, I did actually write it down. It says, make sure that incomplete origin is on all routers. So I can apply my route map in several locations. I can apply the route map when I'm advertising these routes to R6. Now, if I apply this route map when I'm advertising the route to R6, the problem is going to be that origin will be incomplete on R6, R2, R5, R4, and R1, but it will not be on R9. That does not include all routers. So I need to somehow apply this route map in such a way that it applies on R9 as well. Now, the good news is that I can actually set the route map on the network statement, which will modify the attributes of the route at the point of their injection into BGP. So they're going to be injected into BGP having this origin incomplete set there. So if I go to R9 and I paste this configuration in, if I do show IPBGP, I should be seeing these three routes advertised, and I can see that they are internal routes. But if I do show IPB, well, actually, I can see it here, silly me. I can see now that they do have an origin incomplete. So now, if I go to R1 and if I do show IPBGP there, I will be seeing these three routes. Actually, not just yet. There we go. I will be seeing these three routes arriving, and they will actually have origin as incomplete, all three of them. So this was relatively easy so far. Now, let's make this task a little bit more complex. Now, I want loopback 100, so this route 10.0.100/24, to be available only on R6, well, including R9. So on R9, this is the injection point. So only on R6, 10.0.1010/24, I want to be available only in AS600, and 10.0.102. There is a little mistake there. Let me correct it. Just got a little bit carried away with numbers there. 102. Need to correct it here as well, just in one more place. Apologies for this. So this is 102. Okay, and I want 10.0.1020/24 to be available only in AS2456. So I need to implement the policy in my BGP such that this first route is available only on R6, so that it's not advertised to R2 and then further on, that this route here for loopback 101 is available only in AS600, and that this 102 route is available only in our confederation, but not in AS100. Now, to make things more fun, this configuration must all be done. So all this policy must be implemented on R9 only. So you are not allowed to modify any other routers to make this work. Let me explain first how I could do this if there was no restriction to do this only on R9. Well, what I could do is I could implement the filter on R6 in the outbound direction towards R2 that allows the routes 101 and 102, but it does not allow route 100. Also, keep in mind that there is that loopback of R9 that we have to keep in mind. Then, on R5's peering towards R4, I could apply the policy in place that allows 10.0.102/24 together with the loopbacks of R2 and R9. Then on R4 towards R1, I could apply the policy that allows the loopbacks of R2, R5, R4, and R9, but it does not allow any of the 10 networks to be applied. So I would need a policy on R6, I would need a policy on R5, and I would need a policy on R4. That's one of the solutions. There are of course alternate solutions, is where I could apply the inbound policy on R2 from R6 for filtering, where I could apply inbound policy from R4 on the peering session between R5 and R4. I could apply an inbound policy on R4, or I could apply an inbound policy on R1, or any combination of those. But because I have prepared my network for using the communities, so I have send community configured on all of these routers. Now, even if I'm not asked to use the communities should come into mind here because they are probably the simplest solution for the problem. Now, what are the communities? So here, just a brief introduction. BGP communities are really just route tags. They have the format of really large number, but convention says to display them as AS number and some identifier. And this is exactly what IP BGP community new format does. Now, this is just a basic. This is what the fundamentally what fundamentally BGP communities are. But some communities have special meaning. Now, this special meaning implies certain behavior by the routers when they have routes in their BGP tables that carry these communities. These communities are referred to with by common name of well-known communities. There are many well-known communities, but the three are of particular interest for you as a CCIE candidate. These are no advertise, no export, and local AS. As I say, there are others that are maybe of some importance. There is an internet community, which, by the way, does really nothing. There is cost community. There is, of course, an extended community like route target. There are OSPF communities, EIGRP communities used for MPLS VPNs. Same here. So there are these lesser important, well-known communities. There is also thing like no peer, which really doesn't have an implied meaning. It's more like a standard community to imply a certain filtering behavior in ISP networks, but the routers won't do anything automatically with it, but you can use this as a standard community to identify the routes that shouldn't be advertised to your peers, but should be advertised to your transit carriers or your customers, for example. Just an idea. But these three here, these are important ones. So these are the ones that you really need to know how they behave. So these are the important communities. So let's take a look at these three. So no advertise is very, very simple community. Do not advertise this route to any peers. So if the router has the route in its BGP table that has the no advertise community, it will not advertise this route to any peers. That's a simple one. Now, no export simply means do not advertise this route to any external peers. Advertise this route not routo, but route to internal and confederation peers. Now let's take a look at local AS. This simply means do not advertise this route to any external or confederation peers. But it means advertise this route to internal peers. So this is what these three communities do. So taking a look at our example here, what is it that we actually need to do? Well, if we are to use the communities to solve this problem, really, for this one that needs to be advertised only to R6, we are going to be using the local AS. This one that needs to stay in AS, sorry, not local AS, oh, silly me. This one that needs to stay only on R6 needs to be no advertised. So no advertise. This one here that needs to stay in AS600 needs to get the local AS. And this one here that needs to stay in AS2456 is going to be no export. But again, the question is, where do we actually apply these communities? Where are we going to use the route map that is going to set this community? Now, if we use this route map on R9, on the network statements that actually inject these routes in BGP, we are going to have a problem, because then R9 will have in its own BGP table these three routes with no advertised local AS and no export communities, which means none of them will actually be advertised to R6. Why? Because no advertise simply means do not advertise. Local AS means keep in your local confederation AS, but if you're not using confederation, keep in your local AS. And this means keep it in AS900. No export means don't advertise to any external peers, which means don't advertise to AS600. Which means that if I use these route maps on the network statements, I'm going to create a trouble for me. Where I need to apply these is actually on this peering session when the routes are being set. So this is where we are going to apply our communities. This is where we need to send the communities. This is where we need to set the communities on our routes. So let's write out these route maps here. So I'm going to need some prefix lists, I'm going to need some route maps, and then I'm going to apply these filters, and we are going to see how this filtering actually happens throughout the network. So for that, I'm of course going to need my notepad. So the first thing that I'm going to do is I'm going to create a prefix list. Let's call it loopback 100. I'm going to say permit 10 0 100 0 /24, and I will need 3 of these. So this will be 101 102. Then I'm going to need route map. Let's say this will be on the outbound direction to R6, so we can say R6 out permit 10. I'm going to say match IP address prefix list loopback 100, and I will say set community no advertise, and I will need 3 of these. So this is 20 30, this changes to 101, this changes to 102. This one here is local AS, and this one here will be no export. Now, if I apply this to my BGP session, so let's go to router BGP 900, address family, IPv4, neighbor 192.168.0.6, route map R6-out in the outbound direction, I will solve the requirements of this task. So let's do that very quickly. So here I am on R9, pasting this in. Now, if I go to R6 and I do show IPBGP, Okay, maybe we need to clear the session, so let's do clear IPBGP star outbound, actually soft out. So now I see that on my R6, I actually do have the community here in my BGP table, and it says here no advertise. About 101, I have the local AS, and 102 has no export. So if I go to R2, if I do show IPBGP, here are my networks, 101 and 102. Network 100 is not present. If I go to R4, if I do show IPBGP, I should be seeing only one of these, and this is 102. And if I go to R1, show IPBGP, I'm going to be seeing none of these networks. However, I have just failed an entire BGP section. Why did I fail the entire BGP section? Because if we go back, one of the very first requirements was that R2's loopback need to be able to ping R9's loopback. Let's give that a go. So if I go to R2 and I try ping 192.168.0.9, source loopback 0, that is now failing. It is now failing because if I take a look at the BGP table, I do not have the route for R9's loopback 0. I have created that problem for myself with this route map here. So when I applied this route map, I am explicitly allowing this, I'm explicitly allowing this, and I'm explicitly allowing this. But there is, just like with access lists, an implicit at the very end deny everything else. Now, I don't know if it's order 99 or if it's no order, but there is an implicit deny at the end. What I need to do is anything that I did not explicitly match to set the community here in this particular case, I actually need this permit statement. Otherwise, I will be filtering out the loopback 0 of R9, basically losing the points for previous tasks. So let's go back here to R9 and let's just add this entry and let me do the soft clear on the session. So if I do show IPBGP now, at this point I should be getting the R9's loopback. So where was I testing this? I was testing it from R2. Let's add loopback number 4. So this fourth loopback that we are going to add on R9 is going to be loopback 103 and let's say 10.0.103.0/24. Now I want this loopback interface to behave in the exact, to have the same behavior as loopback 102. So I wanted to have the no export community set and I want it to be advertised there. So the solution for this task should be relatively simple. So what I'm going to do is I'm going to go to R9. I'm going to say interface loopback 103, IP address 10.0.103.9, like so. Going to go into the BGP, and here I'm going to show you a little cheating trick. So the cheating trick here was that I couldn't be bothered to select, paste, select, paste, select, paste. I just copy pasted everything until the line that I actually needed to have. Which is okay because I'm just repeating commands that are already in place. Let me add the prefix list. So it's going to be IP prefix list. Let me use the notepad for that. So I'm going to add the new prefix list. Even though technically speaking I don't have to add new prefix list, I can actually modify this one. So let's do that. Like this. So if I do now let me remove this one. So here in a single access list, in a single prefix list line, I'm allowing 10.0.1020/23, but I'm allowing the subnet /24 subnets of this, and 2/24 subnets of this are going to be 102 and 103, exactly what I need. So if I go to R6 here, if I do take a look at 102, it should have no export. If I take a look at 103, it should have community no export set. So with minimal modifications, I have actually made the change that I needed. And just to confirm, I should have this route here on R4, but I should not have this route on R1. Now, this is the setup for the next bit. The next bit is I want this loop back here, this loopback 103, I want it to be available on R1. In other words, I want to make R4 ignore the community instruction. I want R4 to actually ignore the no export community. So basically, ignore, I'm going to put it under quotes because you cannot ignore it, you have to do something else. Ignore no export on 103 subnet. Well, to do that, what I need to do is actually configure an inbound route map to take care of it. So let me show you how that will work. So I'm configuring now an inbound route map, so I'm going to say route map R5-in, and I'm going to create a prefix list, IP prefix list, loopback 103, permit 10.0.1030/24, and here I'm going to say match IP address prefix list loopback 103, and I'm going to say set community none. Now don't forget that you have that deny everything else, so I'm just going to permit all other routes. And then here I'm going to say router BGP 400 address family IPv4 neighbor 192.168.45.5 route map R5 in the inbound direction. So if I apply this to my R4, clear IPBGP star soft in, if I do show IPBGP 10.0.1020, this one will have no export, but 103 here no longer has no export. So if I go to R1, if I do show IPBGP, I'm going to see it available on R1. So this solution works. But this is very, very brute force solution. Basically what I've done here is I have removed all the communities. Not only no export, but I have removed all other communities that might be there. Now the task could have been worded, do not affect any other communities that may have been set on this route. What other communities are there? Well, we don't know, but let's give it a try. So here on R9, I do have that one route map. So do show run section route map. So let's find that entry, this one here. Let's say instead of simply set community no export, let's add a couple more communities. Let's add, for example, 900, 900, 911, 900, 151, and so on. So whatever the list might be there. So some generic random list of communities. So if I go to R4 now, and let me just clear that session. So clear IPBGP star soft out. So if I go to R4, and if I take a look at network 102, of course, every time I want to use soft out, that doesn't quite There we go. So now for network 102, I have this list of communities. So there is no export, but there is this other random list. If I take a look at network 103, with our set community none, I have basically deleted this whole list. But what if the task told me, make sure that other communities are not impacted with your solution? Well, if that is the case, this solution here does not work. What I need is a way to actually take only that one community out, that no export community. That can also be done. So this is an alternate, more precise solution. This stays. What I need now is IP community list. And just like with access list, it needs to have some numbers. So I'm just going to give it 1. And I'm going to say permit no export. So I'm creating a community list that matches just no export community. And here, in my route map, so I'm first going to remove this set community none. I'm going to say set com-list1 delete. Basically what I'm doing now is I'm telling the router, if you find a community that matches the access list 1, the community list 1, delete it. All other communities should be unaffected. So let me paste this in now on R4. So this goes in. This goes in. I'm going to remove set community none and going to add set com list delete. Now let's do clear IPBGP star soft in, and if I do show IPBGP 10 0 1 0 2 0 and 1 0 3 0. Okay, let's clear it one more time just to make sure that the route map is correct. It is correct. Okay, maybe I'm going to be, there it is. So, network 10.0.10.30, take a look at this now. All other communities that have been set are still there, they are intact. So with this solution that I applied now, I have just sniped out that one community that I cared about. So now on R1, I have this network in just like before, and on this router here, show IPBGP, oh sorry, 10.0.1.0.3.0, I have all those communities intact. Now, I have not been asked to install these communities there. I just use them as an example to show you what the requirement of make sure that other communities are intact with your solution might actually mean. Do I recommend using set community internet when clearing the communities? Well, yeah, sure, why not? I mean, internet community really has no special meaning. It's one of those informative communities. Oh, these are the internet routes. So yeah, you can use it. You can also use set community none. But keep in mind that when you use set community, what you are doing is, okay, let's take a look at the example here. So another task. So let me clean this up just a little bit. Actually, not going to clean it up, going to add it here. Now, the next task is when advertising to R1, so when advertising to R1, 103 network should have community internet set in addition to other communities. Or let's say, let me reword that so that to make it a little bit more vague. Should have internet community set other communities should be intact. Okay, so now I want to create a route map towards R1, and this one route should have this community set. Actually, let me put it this way. Actually, this will allow me to show you one more thing. All routes advertised from R4 to R1 should have community internet set. All other communities should be intact. Well, that should be easy. Let's go to R4. Actually, let's do the notepad first. So I'm going to create a route map, and this will be R1 out, and I'm going to say set community internet. Then router BGP, what was it, 400, address family IPv4, neighbor 192.168.14.1, route map R4-out, oh, actually it's R1-out in the outbound direction. So let's paste this in to R4. Okay, so this goes in, and let's say clear IPBGP star soft out. So if I go to R1 and if I do show IPBGP 192.168.0.9, I see that 0.9 has the community internet set. All good. Now let's take a look at this route here. Take a look at this. It says set community internet. Well, that's what I did. There it is, the internet community. But if I take a look at R4, this 103 route had some other communities configured. So my set community internet here in this solution here has actually deleted this community list here, and it has replaced it with this list here. So this set community internet, just like set community none, will actually delete the existing communities, all of them, and replace the whole list with just that one community internet. But my task here had quite a different requirement. It said that all routes should have community internet set, other communities should be intact. Now, in my case here, were they intact? No, they were not intact, they were actually removed. So in this case, I should use additive keyword. Now, what this will do is it will append the internet community to an existing list of communities. If there is no existing list, the new list will be created. So let's put this in on R4. So if I do clear IPBGP soft out, now if I go to R1, if I take a look at 192.168.0.9, I still have the same thing, but if I take a look at my 103 route, I now have internet community set, and I have those other communities installed. So using set community internet to remove other communities is okay, but so is using set community none, because you are going to have pretty much the same effect in a sense that you will be removing an existing list. But sometimes this may not be what you want to do. As opposed to using set community list in my previous example to delete that one community, can I just copy the existing list of communities and simply use them to replace? Well, you could if they existed, but the task was deliberately vague. The task here says other communities should be intact, but it doesn't tell you what other communities are. So your solution needs to take into account any possible set of communities. So if you have a list of communities, yeah, you could theoretically use it, but if the question is vague like that and you don't actually have any other communities on the route, what list are you going to use? Do you know what are they going to be using in a grading script to verify your solution? You don't know that. So when you are faced with a task that might look like this, don't think too much. Find a generic solution that will work no matter what they throw at you.